Hi friends, I'm Shravana and welcome to Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, in today's video, we will see the code for removing any node from a linked list. In the previous video, we have seen how to insert a node at the given index, right? Similarly, for a given index, if we wanted to remove the node, right? For that, we will see the code today. So, I took some online compiler, friends, as I'm just repeating this every day because some new people might be joining, right? So, you just Google for any Python online compiler and you just randomly pick up anything you want. You will get a editor like this. So here you can write the code in the left side and you can click on this run button and right side you will see the code. Okay. Now we are talking about removing any node from the linked list, correct? So for that I am creating a method called remove. And here we have to have the index to be passed, correct? Because we need to know for which index we wanted to remove the value from the linked list. So here I am using the remove method. Now let's go back to this linked list diagram. Now when you say removing an element from the linked list, again there are multiple cases we have to consider. First of all, when the user is passing the index as input to this remove method, we should validate that first. What kind of validation? It should not be a negative index, correct? That is the first thing, because it starts with 0, 1, 2, 3, 4 and goes on. How many elements are there in the linked list? Based on that, those many indexes will be populated. Now, let's say if the user is entering -1 or some 6 here or 5, more than 5, 10. Let's say 10, index 10 like that. If the user is entering passing as input, right? Then we should invalidate such kind of cases. Correct? So, that is our first case. Now, let's write the code for that. If index is, it should be always greater than 0. So we say if the index is less than 0 or index is greater than or equal to self dot length. It should not the index should not be after this overall length of the linked list, correct? So with that we will say return none or false, anything is fine based on how you wanted to capture the return variable from this method. So first case is that one. So we should invalidate any indexes that are being passed as negative values or the more than the length of the linked list. Fine. Now what is the second thing that we have to consider? Let's say if we wanted to remove the first element which is present in the 0th position. This is the first node of this linked list. So friends, I hope you remember we have seen one method called pop first for removing the first element from a linked list, correct? So now we will reuse that method here for popping the first element from this linked list. So in case if index equal to 0, then we will say call the pop first method. Got it? So if the index is 0. So hope you remember the pop first method, right? What we have done. So in the pop first method, we have just verified that the list is not empty. And if it is empty, then what we have done, we have created a temporary pointer for taking that head. And we here, if you just add it here, right? So if we wanted to remove this particular first one, we have to move this head to this second one and this pointer to be pointed to none. So these things we have done as part of pop first. And now we are calling that here. Correct? So that the first element will be populated. So why we have to have this is so that the code will be faster. In case of these kind of cases, if we have considered, then it will be faster. Correct? Now let's say if index is at the last. Now we have seen removing the first element. Now we will see how to remove the last element of the linked list. So now here self dot length. Correct? If the index is self dot length, it's already reached the fifth, 4. Here we cannot take 5 like how we have taken in the previous, correct? because now at the fifth position it will insert based on the index, but now here we have fourth one as the index, latest index, right? So we have to take that as -1. Length is 5. So in case if we are entering the index as 4, which is 5 minus 1 equal to 4, then we can call the pop method. Hope you have remembered the pop method. So pop method, what it will do, it will remove the last element from the linked list. So for that what we have done is we have moved the tail to the previous node and this pointer to none, correct? I hope you remember that pop method also. If not, please go through the previous videos in the data structures and algorithm series. Okay, now uh, we have invalidated that what is that indexes, invalid indexes. We have seen how to pop the first element of a linked list and then last element of the linked list, correct? Now we are calling the pop method for that, so that the last element will be removed. Now whatever is in the middle, so here somewhere you wanted to remove, let's say you wanted to remove the second index, which is 30 you wanted to remove. So first what we have to do, for getting to this position we have to have one element which is the previous element, correct? In the previous video also we have seen we need this kind of temporary variable so that we can just access it as dot next, so that for this we have to change the pointer position, correct? So we will say whatever position that index, whatever index that we are going to remove, you take the previous indexed node and assign that to this variable called prev. Okay, now what we have to do, what now this whatever we are going to remove, that will become your current, correct? This is your current variable. Okay, now we have previous and the current, so this part is clear, right? Now what we have to do, we have to create one pointer from here to here, because this will be removed in between. So previous dot next equal to current dot next. Current dot next is nothing but here, so previous dot next equal to current dot next. So we are writing one line to have the connection between 20 and 40 by ignoring the connection to the 30, which is in the index 2. Okay, and then what we will do, whatever is current is here, right? Here this pointer we will assign it to none, so that it will not point to 40 anymore. Okay, now let's write that in the code. So first what we thought, we'll create a previous variable, correct? So now let's take that as prev. What is that previous? It is the one index before the current index, whatever index we are trying, right? For that, so now I'll say self get index. So here already we have the get index, get method created here. I'm reusing this function. You, if you want, you can write the code again for that. Okay, so we have to have the previous index of the current one. So what is the one that is currently that we have here? It's nothing but the previous dot next, correct? Previous dot next, which is the current, which is the current. Current is this 30th node. This is the current. Next what we have to do, we have to have this connection between 20 and 40. 20 and 40. What is the 20 and 40 means? Prev dot next equal to current dot next. Okay, so from 20 to of next equal to this current dot next is nothing but this 40. So this connection we have established, this particular 20 to 40 connection we have established, and now we have to remove this particular current dot next, right? To none. Current dot next equal to none, so that it will no more point to the 40th node. And because we are removing the length here, I mean we are removing one node from the entire linked list, we have to reduce the length here, and then we will say we will return the current this one, current node. Okay, now this is what we are doing in the remove. So that, see here we have the linked list like this. So now first we have to get the previous index, and then it will become the current. Previous of next of previous will become the current, and then we have to have this connection between previous and the current dot next, and then finally this pointer we will point to the none, so that this will be ignored, means it will be discarded from this linked list, because this pointer is already pointed to 40 and this pointer is pointed to null. So all this 30 and this pointer, this node will become like empty. I mean, it's not connected to the linked list anymore. So now we have wrote the code for remove. Now let's run that. So now we have this till display, we have the code. Now dot remove, we say second one we thought of removing, right, which is 30. Yeah, and then we will again call the display method. Now you can see the 30, if you see here 10 20 30 is removed and then 40 50 are there. Okay, now length is reduced by 1. Okay, now like this we can remove an element from the linked list. Hope this is useful for you friends. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.